The last thing we're going to look at in this chapter is function composition and inverse functions. So an inverse function, inverse, is a function in reverse. So f of x takes x, puts it through the function, gets an answer of y. The inverse takes y, puts it through the inverse, and gets you back to where you started. So it undoes what the function did. So the function takes x, maps it onto y. The inverse takes y and maps it onto x. So the question today is this. What do you think happens when we take the inverse of f of x? So it means we're starting with an x. We're putting it through the function, and we're getting a y value. Then we're calculating the inverse of that. Where do you think we end up? What if we did the opposite? What if we did the inverse first? We're going to calculate the inverse of x, and you might be saying, those are y's. So generally, when you write a function, you call the input x. Because we have a picture of y here, I'll just change it to y, so hopefully you can see better what's happening. So what if you started with y, calculated the inverse, and then calculated the function value of that? Where would you end up? And that's what we're going to answer today. So let's start first by calculating an inverse. F of x equals 3x minus 5 is the same as saying y equals 3x minus 5. So a function takes x, maps it onto y. The inverse takes y and maps it onto x. So if the function was solved for y, the inverse, we'd solve for x. So let's try that. We're going to get x by itself. We'd start by adding 5 to both sides, divide by 3, and there's our inverse. There's a completely different way of thinking about this. When you take your function, you start with an x, you multiply by 3, and then you subtract 5, and that gives you your y value. So you take your x, multiply by 3, subtract 5, that gives you y. How would you undo what you just did? If subtracting 5 is the last thing you did, the opposite of that would be adding 5. If multiplying by 3 was the first thing you did, the opposite would be dividing by 3. So you start with y, add 5, divide by 3, and that gives you x. Isn't that delightful? So all we did is undo what we did going forward. Now, we have said that when you write a function, you normally write it as a function of x, not as a function of y. So really, when we write this as a function, the standard notation, instead of writing our input as y, we'd write it as x, and our inverse would look like this. So the inverse function looks like that, and it's written as f to the minus 1, which just means function going backwards, so inverse function. Now, some of you might have seen this a different way. Some of you might have heard your teachers say to find an inverse, swap x and y. Okay, so instead of y, we'd call it x. Instead of x, we'd call it y. And then you solve for y. So add 5 to both sides. Trying to get y by itself. So you divide both sides by 3. And so we have x plus 5 over 3. And that is equal to y, which is exactly what we expected over here, as long as you can see that that's an x. So whether you do this by saying, I'm going to solve for x and then put it in the standard form, which is making your input x and your output y, or switching x and y right away, you will end up with the same answer. So the long answer is, this is our inverse function. Now, what the question was, is what happens when you calculate the function of the inverse, or the inverse of the function, and the answer is you end up exactly where you started. So if you start with x, calculate the inverse, then calculate the function, you go back to the start. If you start with a function and calculate f of x, then do the inverse, you go back to where you started with. So the function undoes the inverse undoes the function. And we're going to prove that. Here's how we do it. F of f inverse x. Start with the inside. F inverse x we calculated to be x plus 5 over 3. So we're replacing f inverse x with x plus 5 over 3. We're now calculating f of that. Now, if you have trouble with this, let me give you an easy way to calculate this. F of x is equal to 3x minus 5. We are calculating f of x plus 5 over 3. So what we've done is we've replaced our x with x plus 5 over 3, and we have to do that everywhere. So if I'm ever having trouble with this, I just write down my function with a bracket wherever my x's are. So there's an x there, I'll put a bracket, and in the bracket, you put what's in the bracket, which is x plus 5 over 3. So we're evaluating the function for an input of x plus 5 over 3. So there's our input. Looks a little bit nicer there. And then we'll clean this up. We can get rid of those, so we have x plus 5 minus 5. We can get rid of those, and we get an answer of x, which is exactly what we were expecting to get. So we started with the inverse, we calculated the function value of it, and the function undoes the inverse and gets you back where you started. Magic. Let's try the other one. Start with the inside function. The inside function is 3x minus 5. We're calculating the inverse. The inverse is this one. Again, if you need a method that's always going to work for you. F inverse. There's an x. I'm going to put a bracket. X plus 5. There's an x. I'm going to put a bracket. We're calculating f inverse of 3x minus 5. So that's what goes in our brackets where the x's were. So that's what the inverse function should look like. 3x minus 5 plus 5 divided by 3. Okay, can we clean that up at all? I think the minus 5 and the 5 will eliminate. 3x over 3, the 3's will eliminate. And there we are back where we started. If anyone's still really shaky on what's happening here, f of x is 3x minus 5. If you were calculating f of 2, what would you do? You'd put 2 in for the x. If you were calculating f of 7, what would you do? You'd put the 7 in for the x. If you were calculating f of anything, what would you do? You'd put the anything in for where the x is. So if you're calculating f of x plus 5 over 3, you put the x plus 5 over 3 in where the x was. So we're just evaluating the function at a particular point. Okay, let's take a really interesting question. Here's the function we're going to look at. We're going to do a lot of things. First, we'll calculate the inverse. Then we'll do that delightful f inverse x is the same as f inverse f of x equals x. Then we'll do some graphing and domains and range. And this should give us a really good understanding of what happens. Let's start with the inverse. So to start with the inverse, y is equal to root x plus 5. We need to get x by itself. We could square both sides. If we did that, that would get rid of the radical. So we'd have y squared equals x plus 5, then bring the 5 over. And then we remember that we're accustomed to writing our input as x and our output as y. So there's the inverse. If you don't like that, and you say, no, I much prefer to swap my x's and y's right away, because that's what I learned, we can do it that way as well. Okay, so square both sides. We'd have x squared equals y plus 5. Get y by itself, and you get x squared minus 5. Same answer, just a different order of doing things. So you do it the way you prefer. Just make sure you come down to the same answer. Okay, let's see if we can do these. F of f inverse. We start on the inside. We said the inverse function was x squared minus 5. So we're replacing the inverse with x squared minus 5. Now we're doing f of x squared minus 5. So f of anything is the square root of that anything plus 5. F of 4 would be root 4 plus 5. F of 1 would be root 1 plus 5. F of x squared minus 5 would be root x squared minus 5 plus 5. And a little nicer looking is this version. All right, what can we do now? I think the minus 5 and the 5 will eliminate each other. And the square root of x squared, I'm sure a lot of people are happy saying, that's x. Yay, I did it. You just have to be a little bit careful. This is a principal square root sign. Principal square root sign says the answer must be positive. So the actual square root of x squared is the absolute value of x, which equals x as long as x is a positive number. So you just have to be a little bit careful. If you skip from here to here most of the time, it's going to work out, but just be aware that there's actually something else going on here. And x is a positive number. So the absolute value of x will be x, so let's not worry about that. The inverse of f of x. This time we start with f of x. And what was f of x equal to? Root x plus 5. Okay, now we're taking the inverse. This is where we have to be a little bit cautious. The inverse of a function the inverse of this function is whatever I give you squared minus 5. So the inverse of x is x squared minus 5. If you were doing f of 4, 4 squared minus 5. F of 10, 10 squared minus 5. F of root x plus 5. Root x plus 5 squared minus 5. A little bit messy. What does it look like when it's nice and neat? And square the radical. We get rid of the radical. Nothing complicated, nothing strange there. And our answer is x. Okay, so once again, we've managed to prove that the function undoes the inverse, leaving us with x. The inverse undoes the function, leaving us with x. Okay, what else do we need to do? We needed to graph it. So our function is root x plus 5. That's a square root graph. It would start at negative 5. Be nice to have another couple of points on this graph. There are a couple of easy points we could plug in here. What if we plugged in an x value of negative 1? Negative 1 plus 5 is 4. Square root of 4 is 2. Can you think of another easy point you could plug in? If I did 4, 4 plus 5 is 9. Square root of 9 is 3. So there's our square root graph. And I'm just going to change the color on that one. So the square root graph goes through those points. Forgive my awful graph, but there is our function. Let's talk about domain and range. Domain of this one starts at negative 5, so we're greater than or equal to negative 5. What about your range? What sorts of y values? Greater than 0. Okay, let's look at the inverse. Now there's a couple of ways of doing the inverse. I'm going to show you my favorite. My favorite is, let's just swap the x and y values. So this is the point negative 5, 0. The inverse then goes through 0, negative 5. Negative 1, 2, the inverse would be 2, negative 1. 4, 3, the inverse would be 3, 4. Why are we allowed to do that? A function takes x to y, and inverse takes y to x. So we just end up swapping all the x and y values. Now, if you want to check if you've done that properly, the two graphs should be mirror images along the line y equals x. Meaning if you were to fold the graph along that line, the two lines would end up on top of each other. And I think that's what we're getting here. So that's my favorite way of doing this. The other thing you can do is look at your domain and range. If we've swapped x's and y's, the domain for this one should be the range from the other one. So if we used to be greater than or equal to 0 for the range, our new domain is greater than or equal to 0. If our domain was greater than or equal to -5, the range is now greater than or equal to -5. So I find the quickest way to do this, swap the points, draw the graph, swap the domain and range, and then check. Is our domain x greater than or equal to 0? Yes, it is. Is our range y greater than or equal to -5? Certainly is. So now we know we're right. For those who might have been tempted to say, why can't I just graph this? Why can't I just take y squared minus 5 and draw myself a picture? It's a parabola, and it looks like that. And that's not what we're getting. We're only getting this part of the parabola. So you have to be careful. This is the inverse of this function. And if it is the inverse of this function, it must end up with a domain that matches the range from the previous one. So if there are any restrictions over here, you must see them over there. So you could have done this. It would have been okay to draw that graph as long as at the end, you take your graph and you say, whoops, didn't mean to include that section. So just be cautious with this. All right, what do we need to do today? Exercise 1 to 5, that's where you're working. It'll be terrific practice for you, good practice of your sketching of graphs, good understanding of what an inverse is, great opportunity to work with function composition, and you always know what the answer is. How nice is that? Have fun.